Good morning, my dear students. Last class we have been discussed about the random experiment outcomes as well as sample space and what is meant by the sample space and how we write the sample space of the given experiments. So today I am going to discuss the new concept, that is event. So what is meant by event? A subset E of a sample space yes is called an event. Is called an event. Any subset E of the sample space S is called as an event. So for example, a coin is tossed twice. A coin is tossed twice. Means coin is tossing two times. And we know that the sample space of this random experiment is, the possible outcomes are both the coin shows head, or first coin is head, second coin shows tail, or first coin shows tail, second coin shows head, or both the coin shows tail. Let us consider a subset of the sample space. That is considered as event. So that is nothing but E. The way of writing is E followed by the colon. And event E is defined by both the coin shows head and the elements present in this event E is E equal to both the coin shows head. So when we toss a coin for two times, that two times, in that two times coin must shows head. So here there exists only one, that is what? H and H. So this set E is subset of this sample space, hence this is called as event of this random experiment or event of this sample space. I hope all of you understood. Let us consider one more event, that is nothing but F. So F is another event and it is defined by getting at least one head. At least one head. At least in the sense greater than or equal to. Means minimum. So we need to write the outcomes which consists at least one head. And the elements of this event F are given by. So at least one head means the outcomes must consist either one head or two head, because coin toss only two times. So therefore the possible outcomes of the event F are one head, that is HT, this is one of the possibility, or TH is also one of the possibility. Only these two outcomes consist one head. And second possibility is the coin or the outcome consists two heads. That is nothing but there exists only one, that is what? H and H. TT is not possible. Why? Because in this outcome the number of heads is equals to 0. But we need only at least one head, in the sense one head or two head. Therefore, these are the only possible outcomes present in the event F. And this F is also subset of this sample space. Hence, this F is called as event of this sample space. I hope all of you understood. If possible, take a look. So now the types of events. So the first one is impossible event. First one is impossible event. And the second one is sure event. Third one is simple event. And the fourth one is compound event. So what is meant by impossible event? So let us consider an example. So example is nothing but coin tossed twice. The sample space consists HH, HT, TH and what? T. So let us consider an example for the event, and event is E. So E event consisting getting 3 heads, and the elements of this event is, we are tossing a coin for 2 times, so we get either 1 head, 0 heads or 2 number of heads. So it is not possible to get 3 heads, therefore the elements present in this event E is nothing. Therefore the event E consisting 0 number of elements, hence E is the null set. So the event corresponding to the null set is called as impossible event. Any event which doesn't consist of any elements, such type of event is called as which type of event? Impossible event. I hope all of you understood. Now the second one, what is meant by the sure event? So let us consider one more example. Let F be another event, and the event is getting at most 2 heads. At most 2 heads. So at most in the sense maximum, it means less than or equal to. So we need to get the at most 2 heads. At most 2 heads means less than or equal to 2 heads, in the sense we may get 0 number of heads, or 1 head, or 2 head. Therefore the possible elements of the event F, or possible outcomes of the event F, are given by. So first, 0 number of heads are present in this outcome. So T is also possible outcome for the event F. And next, 1 number of heads are present in second and third. Therefore HT as well as TH. And 2 number of heads present in the first outcome. Therefore HH. And now you observe that this F is equal to the sample space, and this event F is called as a sure event. The definition is any event corresponding to sample space is called as what? Sure event. I hope all of you understood. Now the third one, what is meant by simple event? So in the sample space there exist 4 outcomes. These are called as outcomes as well as sample points. The outcomes of the sample space, ಏನಂತ ಕರಿತೀವಿ ನೋಡಿ ಹೆಸರು? Sample points or outcomes are what? Results of the random experiment. HT is a outcome of the random experiment, or result of the random experiment, or sample point of this sample space. I hope all of you understand. Let us consider one more event, that is what? G. So G is nothing but getting 2 tails. Getting 2 tails. So hence the event G consisting the elements, those outcomes which consist only 2 number of tails. So there is nothing but only this one is the 4th result, that is what? TT. So T and T. Now only outcome present in this event G, hence G is called as a simple event. So the definition is any event which consists only one sample point. Any event which consists only one sample point, that event is called as a simple event. I hope all of you understood. And the 4th one is compound event. What is meant by compound event? F is also one of the compound event. So compound event means any event which consists more than one sample points. Any event which consists more than one sample point is called as a compound event. Why? Because here F is consisting more than one sample point, that is 4 number of sample points are present in the event F. Hence this event F is called as what? Compound event. I hope all of you understood. If possible, take a note. So now the next concept is algebra of events. Means union of two events, intersection of two events, or complementary of an event. The first one is A or B event. The mathematical representation of A or B event is A union B, and the second one is A and B event. A and B event. The mathematical representation of A and B event is A intersection B, and the third one is complementary event. Complementary event. And for example, the complementary event of the event A is denoted by A complement, and which is defined by S minus A. So A complement is equals to S minus A, where S is the sample space associated with the random experiment. So means all the elements belongs to the sample space but not belongs to the event A is what? A complement. And now the fourth one is A but not B event. A but not B event means all the elements belongs to the event A but not belongs to the event B is denoted by A minus B. A minus B means all the elements or outcomes or results belongs to the event A but not belongs to the event B. This is the mathematical representation of the event A but not B. I hope all of you understand. Now the fifth one is mutually exclusive events. Mutually exclusive events. So what is meant by mutually exclusive events? Two events A and B, two events A and B are said to be mutually exclusive events if A intersection B should be equal to null set. Then we call that these two events are mutually exclusive events. I repeat once, two events A and B are said to be mutually exclusive events if A intersection B is equal to null set. Or in other words, if A intersection B equal to null set, then we say that the events A and B are mutually exclusive events. Let us consider an example. For example, a die is thrown. A die is thrown once, and the sample space associated with this random experiment is, so die is thrown means the possible outcomes are 1, 2, 3, 4, 5 or 6. Let us consider the events. Let A be one of the events, and which is defined by getting even number, and B be another event getting odd number. Therefore, the elements of the A event are given by getting an even number 2, 4 or 6. The elements present in the event A are 2, 4, 6. Elements are sample points or outcomes are results. And B is another event which consists only odd numbers, means either 1, 3 or 5. 1, 3 or 5. Now what is A intersection B here? A intersection B means the common elements present in A and B. Which elements are similar in both A and B? That elements are present in A intersection B. So the event A consists only Event B consists only odd numbers. It means there does not exist any common elements between A and B. Hence A intersection B doesn't consist any elements. So it means A intersection B is equals to null set, or null set can also be represented like this. Since here A intersection B equals to null set, hence these two events A and B are called as which type of events? Mutually exclusive events. I hope all of you understood. Still there exist two events, mutually exhaustive events, and seventh one is mutually exclusive and exhaustive events. I hope all of you understood. If possible, take a note. Now the sixth one is exhaustive events. Two events A and B are said to be exhaustive events if A union B is equals to S, where S is the sample space associated with random experiment. I repeat once. Two events A and B are said to be exhaustive events if A union B is equals to yes. Let us consider the example. So same example which is described here, that is a die is thrown once. The sample space consisting the elements 1, 2, 3, 4 and 5, 6. And let A be the event getting an even number, B be the event getting an odd number. So therefore event A consisting getting an even number means 2, 4, 6. 2, 4, 6. And the event B consisting the elements odd numbers, that is 1, 3, 5. So 1, 3, 5. So what is A union B here? A union B means elements present in A or B or both A and B. So that is nothing but 1, 2, 3, 4, 5 and 6. So the elements of A union B are 1, 2, 3, 4, 5 and 6. And now this is equal to the sample space S. And hence these two events A and B are called as exhaustive events. I hope all of you understood. And now the seventh one is mutually exclusive and exhaustive events. And what? Exhaustive events. Now, so two events A and B, are said to be mutually exclusive and exhaustive events if A intersection B is equals to null set as well as A union B should be equal to S, where S is the sample space associated with the random experiment. So let us consider the example which is described here only. So A consisting the elements 2, 4, 6 and the event B consisting the elements 1, 3, 5. Therefore, what is A intersection B? So as you know that already, A intersection B is equals to what? Null set. And what is A union B? So A union B is equals to what? Sample space S. So A union B is equals to sample space S. Therefore, these two events A and B are called as which type of events? Mutually exclusive and exhaustive events. I hope all of you understood. Still we consider some more examples. So I hope all of you understood. If possible, take a note.